Good afternoon. I want to start by first apologising to everyone in the audience. The following speech is going to be very dry, boring, and probably make most of you fall asleep. No, but seriously, the first section of the report involves a lot of economic terms and calculations. However, if you stick with me, there's some very interesting stuff towards the middle. Now that we've got the disclaimer out of the way, let's do this. Today I'll be examining the social benefits of improved waste management practices across Penrith LGA. The first section of today's speech will present the findings of an amenity economic analysis conducted in collaboration with Western Sydney University. To examine the social benefits of improved waste management practices, a cost-benefit analysis was conducted. This examined three key areas, including increased amenity, reduced cost to council, and a reduction in producer and consumer surplus from developments, with subcategories outlined under each. First, we examine the increased cost placed upon Penrith Council through the poor waste collection infrastructure. This revealed costs in regards to recontracting, building repair, waste ranger program, and educational and complaint resolution. Additionally, to allow the calculations, the following parameters were implemented for the analysis. This included a 30-year timeframe, inflation factored at 3%, development growth calculated at 1.175%, and all figures discounted back using a rate of 7%. The table is broken into 4 columns, including category, assumptions, annual cost to council, and present value or present discounted value. That is the current worth of a future sum of money given a specified rate of return. First is waste management contracts, which looks at the additional costs imposed to council by poor waste management infrastructure. As waste contracts are typically 10 years, infrastructure requires renegotiations for smaller waste collection vehicles, runners, collect and return, and different service provisions. As a result, this has imposed an additional annual cost of approximately $99,000 and a present value of $21 million over a 30-year period. Building repairs and the additional operational costs imposed when heavy rigid vehicles operating outside of their design specifications. This is the movement of a truck down single service laneways, taking out gutters, eaves, clotheslines during the collection arm manoeuvres. Then, waste rangers are full-time officers investigating reports of illegal dumping across Penrith LGA. Council employs 2 full-time officers to address these concerns. From the study, it was assumed that 60% of the workload was due to poor waste management infrastructure within the new developments. This resulted in an annual cost of $79,000 with a present value of $1.75 million. Education relates to Council's resource recovery field team, comprised of 4 to 6 staff working to the preparation of flyers, bin inspections, and various audits. For the study, it was calculated that each development requires 4 hours at $50 an hour, coupled with an average of 15 complaints per week, giving an annual cost of $118,000 and a present value of $2.6 million. In total, poor waste infrastructure results in the additional costs of approximately $296,000 per annum with a present value of $6.5 million. Okay, now this is where it gets very dry, but I promise I'll do my best to make it as painless as possible. The next section will examine the costs attributed to waste amenity outcomes of poor waste collection infrastructure. For the study, 2 methods were calculated for the report. The first is revealed preference model. It's the economic theory that identifies the best way to measure consumer preference is to observe their purchasing power. The second is stated preference. It's the survey of individuals and measures their willingness to pay for improved outcomes. For the amenity analysis, the benefit transfer method was chosen, which is basically a combination of the first 2. This uses established like values in literature and applies them to the local context, that is, waste infrastructure. The following journals were discussed in the report. The first is by Domingos, which examined 44 stated preference studies, which allowed an individual's willingness to pay for waste collection infrastructure to be calculated per dwelling. This revealed a total of $135 with respective confidence intervals of $99 and $171. Just quickly, a confidence interval reveals if a population was sampled, the true parameter will fall within the two defined limits, the upper and lower, 95% of the time when calculated. Therefore, using the willingness to pay, the waste amenity calculations for MUDs and households were examined using the following formula. Willingness to pay multiplied by the number of dwellings. For MUDs, it revealed approximately $1.3 million and $27.3 million over the 30 years. The second study was conducted by Donovan and Buttrey, implemented a hedonic price method to value both street trees and curb appeal. The hedonic price method states that a good is a collection of attributes and a price is reflective of those. This research revealed property prices increased between 2 to 9% due to street trees and subsequent curb appeal, and half a tree accounted for 3%. Therefore, curbside presentation and collection of bins will result in a respective devaluation through the removal of the amenity factors. This figure was used to represent the effects of curbside bin presentation. The depreciation value was 3% per dwelling. Using a median house price of $477,000, the amenity impact of 3% was applied. Then using the MUDs, the amenity value was calculated at $135 million. That is, if every MUD had poor waste management infrastructure. And lastly, yes, we're almost there. Research by Wardman examined the effects of reduced litter and fly tipping or illegal dumping. His research identified individuals' households had a willingness to pay of $4.14 per 1% reduction in litter, with respective confidence intervals of $3.39 and $6.78. To calculate the effects of reduced litter within MUDs, it was assumed that integrated waste collection infrastructure is consistent with a 20% reduction in litter. Using this percentage, that is 20 times 4.14, multiplied by the number of dwellings, gave an annual willingness to pay of approximately $800,000 and a present value of $16.8 million. And subsequently for fly tipping, with research identified, 16 million. Oh, good, sorry. And subsequently we've There we go, sorry. And for fly tipping, their research identified an individual's willingness to pay was $106.80 for a 10% improvement in waste collection. Through audit data, MUDs in Penrith accounted for 60% of fly tipping. This results in a willingness to pay of $642 per year, and for the study, fly tipping only affected 25% of the population. This results in an annual willingness to pay of approximately $32.5 million and a present value of $694 million. The following table provides a summary of the values obtained across the three studies. The true amenity value for the study, we believe, falls between 27 and 205 million over the 30 years. However, to get a true calculation, a more in-depth study is required to perform both a revealed and stated preference model. We did it. My head hurts too. Now let's get into something slightly less boring. So building upon amenity study, I recently completed a Masters of Urban and Regional Planning. I examined the following area: reconfiguring residential waste for urban consolidation, evaluating the amenity outcomes of planning policy for integrated on-site waste collection systems with Penrith LGA. Talk about a mouthful, I don't even know what that means. The literature review analysed various sections. However, a key area was the in-depth analysis of New South Wales policy. The analysis examined the following documents: the war strategy, we're all aware of this one, which includes various targets and objectives for the reduction of waste, recycling and landfill by 2022. SEP 65 has only 2 objectives out of a 100-page document. However, these are high level with minimal development-specific controls. Penrith LEP, Clause 7.7 outlines the requirements for all lots servicing provisions, including water, sewer and public amenities. However, waste is not referenced within the required provisions of service. Therefore, the provision of waste infrastructure is solely through the development control plans. It is important to note that LEPs and SEPs unlike LEPs and SEPs, the DCP documents are not statutory documents when contested in a court environment. And finally, the DCP. Penrith has amended the DCP to implement development-specific controls for subdivisions, multi-unit dwellings and residential flat buildings. However, prior to 2016, there were limited provisions within the original DCP. The most explicit was the development of 7 or more dwellings were to provide a communal waste collection area, and the provisions for residential flat buildings were uncertain, with the DCP simply explaining the requirements will be determined on a case-by-case basis, highlighting the limited waste provisions throughout all critical policy documents. The first section of the report provided an infrastructure analysis across Penrith LGA. This examined existing infrastructure of both medium and high density dwellings. This enabled a visual representation of the impacts of poor waste infrastructure has upon amenity. The analysis allowed the identification of 3 critical values for waste amenity, including visual, odour and noise. These coefficients will be used later in the report. The second section explores the impacts of curbside bin presentation has upon a region's transition towards higher density dwellings. St Mary's was chosen for the respective study. The region has undergone dramatic transformations from low to high density over the last decade, where single detached dwellings are being replaced with townhouses consisting of between 3 to 6 dwellings per lot. The analysis used satellite images to track the changes over the respective periods, including 2009, 2013, and 2017. To facilitate the analysis, the area was broken down into key quadrants to allow comparisons and trends. For the analysis, the formula was developed to provide the unobstructed curbside area available. This is comprised of multiple variables including gross curbside area, non-residential frontages, number of lots, car parking and driveway widths. As you can see, there is a substantial difference between gross curbside area available and unobstructed area available for bin presentation. A diagram has been created to show a typical area for curbside bin presentation. This shows curbside area required for bin presentation. The formula was developed in accordance with Council's DCP and service provisions. It includes the number of lots, average lot size, and area required for bin presentation. This calculation shows the true impacts urban densification has upon curbside bin presentation. As you can see, areas 4 and 5 require a greater area than what is currently available to permit curbside collection. The third part of the thesis modelled the amenity outcomes between 2 waste collection practices, integrated on-site waste collection and curbside bin presentation. A recently approved development application was used for the study. The building comprised of a 6-storey residential flat building which included 103 dwellings and 2 levels of basement car parking. The first model examined the impacts of curbside bin presentation within the development. The formula was developed in accordance with Council's DCP and waste provisions. Under this model, the building would be allocated 104 240-litre bins, collected 3 times weekly. This would require an area of 104 metres, which accounts to 81% of the site's available frontage. Please note this does not take into consideration street trees, power lines, on-street parking, and other obstructions. As outlined in the first part of the thesis, the waste coefficients, visual, odour, and noise were used to develop the amenity calculation. This was achieved through the hedonic price model. Using the benefit transfer model, the amenity values were applied to the residential flat building development. A conceptual waste disamenity formula was developed to calculate the amenity impacts of poor waste infrastructure has upon dwelling prices. That is, curbside bin presentation. The formula included average unit price, number of units, and the 3 amenity coefficients including noise, odour, and visual. The coefficients were divided by 2 as the bins were only presented curbside during the respective days of collection, that is, for half the week. Taking into account they were presented the night before and brought back the night after. Using the formula, the amenity impacts per unit were calculated at approximately 23,000 and approximately 2.4 million for the entire development. That is, the devaluation observed due to poor waste collection infrastructure. The second model examined the effects of an integrated on-site waste collection solution within the same residential flat building. This is observed through the respective architectural plans. As you can see in basement 1, you've got dual chutes, linear track, alloy key, and on ground floor, an on-site loading bay, waste collection room, bulky waste room, and chute cupboards. Next on level 1 is the waste chute room and the void required to accommodate council's 10.5 metre heavy rigid vehicle. To develop a conceptual cost of integrated on-site waste collection infrastructure, the cost of the development and the floor area were derived from the DA application. This enabled an indicative cost per square metre to be calculated. Using the architectural plans, the area allocated to waste infrastructure was calculated at 396.8 metres squared. This revealed the waste infrastructure accounted for 3.48% of the total floor area of the site, equivalent to a value of $730,000. The comparison of the two tables shows the values associated with two waste collection configurations proposed within the same development, showing integrated on-site collection has a conceptual value of $730,000 to implement infrastructure versus a conceptual loss of $23,000 per dwelling or $2.4 million for the entire development due to poor waste amenity. This further supports Penrith Council's revised DCP and guideline provisions requiring on-site collection within new residential flat buildings. There are good reasons for explaining and deriving the values of improved waste management practices. However, by itself, this will not simply be enough to drive change because governments at all levels are under pressure to approve developments. In addition, due to the information asymmetries, improved waste management practices are not reflected in the price of the units, and developers have no long-term financial interest in their buildings. Information asymmetries arise when one party in a transaction has more information than the other. Buyers do not have perfect information regarding waste management processes, whereas sellers are aware of their waste management infrastructure. The uninformed buyers pay a higher price in comparison to an informed buyer. The lack of knowledge leads to the loss in social welfare and a transfer of welfare from consumers to producers. The obvious solution to address the poor waste management practices is to adjust the LEP and DCP so that improved practice is legally binding by developers. However, development pressure means this is unlikely to occur. However, environmental bonds may provide a way to implement ownership to the developers. The bond may vary depending on the degree to which the developer alleviates uncertainty. That is, if the developer puts more effort into investigating potential environmental impacts, alleviating uncertainty, they would pay a smaller bond. This bond would also be repaid, and dividends for the bond would accrue throughout this period. Thus, the bond acts as an investment for the developer, but they are still incentivized to minimize the size of the bond by demonstrating the minimal environmental impact and acting ethically. Rather than taxing producers for bad behavior, environmental bonds directly incentivize good behavior. And now to end on a positive note, working in waste services, we often hear a lot about poor waste infrastructure, retrofitted solutions, and you have to sit through boring talks about the importance of waste and amenity. However, to show the true value of price and amenity, I wanted to show you a recent project we have been working on. The project comprised of 5 DA-approved residential flat buildings comprised of 653 units with a gross construction value of $168 million. As the buildings were approved under the old DCP, they were required to present 653 240-litre bins curbside across the 5 sites. That is 0.65 kilometres of bins presented curbside. However, following countless colourful discussions and developer education on Council's new DCP, I was able to get the developer to agree to lodge Section 96 modifications to incorporate on-site waste collection infrastructure within each of the sites. This included on-site loading bays, dual chutes, linear track system, bin tug devices, waste collection rooms, and bulky waste rooms. This shows the growing importance of waste collection infrastructure and the transition of waste as a byproduct to a fundamental and essential component of the development application process, highlighting integrated on-site waste collection infrastructure as a critical component to addressing the changes proposed by urban consolidation and high density dwellings. Thank you.